Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to see the topic AC and DC characteristics of the operational amplifier. So this is the outline of this video. So introduction to the operational amplifier. Operational amplifier is best of all the amplifiers. Why? Because it can amplify the weak electrical signals with higher gain. So that is the main purpose of the operational amplifier, and it is originally designed for mathematical operations like addition, subtraction, integration, logarithmic, anti-logarithmic, such applications. So this here is the symbol of the operational amplifier with two input signals, inverting input and non-inverting input, and two power supplies and one output. So the main features is nothing but versatility, foundation of electronics, and it is with such features it is used in audio systems, communication devices and control systems. The performance of the operational amplifier can be measured based on the AC input signal and DC signal given to the input path of the operational amplifier. So first part is DC characteristics. So when there is no input signal given to the operational amplifier, some of the signal from the DC power supply flows to the input path of the operational amplifier, which deviates the output of the operational amplifier practically. So this is the case what happens in the operational amplifier. So based on that one, we are having four different characteristics. So that is input bias current, input offset current, input offset voltage and thermal drift. Input bias current. So this is represented as the average of the currents in the input path of the operational amplifier in the two terminals, that is inverting and non-inverting, both terminals. So that is represented as the input bias current IB, which is equal to IB1 plus IB2 divided by 2. Similarly, input offset current. So here the input offset current is represented as the difference between the bias current given to the two input terminals of the operational amplifier. So this input offset current is represented as I suffix IOS, which is equal to IB1 minus IB2. So similarly, the next characteristics is represented as input offset voltage. So here when there is no input is given, so some of the signal from the power supply will flow through the input path and produces millivolts of output when there is no AC input signal is given to the operational amplifier. So this will deviate its output. So in order to reduce this millivolt output from the voltage output path to 0, we will be giving some additional voltage in the input path of the operational amplifier, that is mentioned as the input offset voltage. Similarly, final one is thermal drift. So this happens due to the heating, due to the overheating of the operational amplifier. So practically when the operational amplifier got heated, its output will be varied based on the normal condition. So that is mentioned as a thermal drift, which can be overcome by carefully printing the circuit board layout and forced cooling, air cooling technique. So coming to the AC characteristics. So this represents the performance of the operational amplifier when the AC input signals are given, and it is focused mainly the gain, bandwidth and slew rate of the operational amplifier. So frequency response. So here ideally when the frequency varies, when frequencies varies from lower to higher, whatever may be the frequency, the gain will become stable. So the gain obtained from the operational amplifier will be stable. So that is the ideal condition, but practically op amp gain decreases at high frequency. So that is shown here in this graph. So final one is slew rate. So which represents the change in the output voltage with respect to the change in the input voltage. So how fast it is changing. So that is mentioned as a denoted as a slew rate. So if you see this diagram, the input waveform and the output waveforms are given. So after a certain time limit of after the input changes, the output change. So that is this difference is represented in the form as delta t. So that is mentioned here as a slew rate. So those AC and DC characteristics both deals with the performance of the operational amplifier, and here in this slide we are seeing the ideal versus practical op amp characteristics. So which shows the basic difference between the whatever we are reading theoretically in the book and whatever happens practically in the operational amplifier when we are connecting in the circuit. Okay, in this video we have seen the introduction to the operational amplifier and AC characteristics, DC characteristics, and ideal versus practical op amp characteristics. And here is the assessment based on the slides that we have seen here. Okay, what does an operational amplifier do? It amplifies the signals. And which of the following is an ideal op amp characteristics? So the given all the answer is right. So what is the average value of the two current flowing in the op amp? So that is average value that represents the input bias current. So that's all about this topic, AC and DC characteristics. Thank you for joining this video. We can join in the next video. Thank you all.